guys, today I'm going to talk about physical properties of alkanes, melting point and solubility. Let's have a quick review about alkanes. Alkanes are hydrocarbons and member of organic compound family. They contain CH only. So for example, the first member of alkane is methane, that is CH4, ethane, that is C2H6, and so on and so forth. And there are two types of alkanes. One is symmetrical alkanes and other is unsymmetrical alkanes. So symmetrical alkanes and unsymmetrical alkanes. Symmetrical alkanes means those alkanes which are same on both sides, or they have a plane of symmetry, so we can cut them from. So for example, if we cut this methane from this area, so both sides of this methane alkane are similar, left side and right side. So this is symmetrical alkane. If you want to have an unsymmetrical alkane, then if you cut it from half of it, then you will see that one half is different than the other half. For example, this is example of unsymmetrical alkane. You cannot cut it from between, and then if you cut it from here, then you can have a plane of symmetry, but if you cut it from here, then it doesn't have any plane of symmetry. Or you can say this is unsymmetrical alkane because this is different structure than this one. So these symmetrical and unsymmetrical alkanes will play a crucial part in when we will determine melting points of alkanes. Okay, I'm going to tell you 3 important points about melting points of alkanes. Number 1 is alkanes have low melting points compared to more polar compounds of comparable size. By the way, if you haven't watched my video about alkanes boiling point, in which I have described the boiling point of alkanes and the factors affecting on the boiling point, please watch that video also. You will get information about the physical properties of alkanes according to their boiling point. In this video you will get information about the melting point and solubility of alkanes. Okay, number point 1, alkanes have low melting points compared to more polar compounds of comparable size. So if we take two compounds which have similar size, for example, number 1 is CH3, CH2 and CH3, the molecular weight, and second is CH3, CHO. This is aldehyde, this is alkane, and this alkane has a VWD interaction, that is van der Waals interactions, and in this one it also has VWD, van der Waals interactions, and DD also. DD is equals to dipole moment. Okay, I'll make another video about interactions, but here you just need to know what type of interactions are present in particular compounds. Alkane has only van der Waals interactions, so this is more polar, this is less polar. The melting point of this compound is minus 190 degrees centigrade. Now see, the minus 190 degrees centigrade, and the melting point of this is minus 121 degree centigrade. So if you see, the minus 190 is much less than the minus 121. So even though both compounds have a similar size, but there is a difference of polarity between these two, and hence the melting point is affected by the polarity. And a compound that are more polar going to have higher melting point, and the compounds that are less polar going to have less melting point, as you can see in this example. So the concept of this point is increasing, so as you can see, increasing strength of intermolecular forces increases the melting point. So as you can see, there are two types of interactions in aldehyde and one type of interaction in alkanes, so that's why there is a difference in melting point of these two different compounds of same size. Now point number 2 is melting point increases as the number of carbons increases because of increased surface area. Okay, so if you have more number of carbons in any compound, that compound is going to have higher melting point. For example, let's see, CH3, CH2, CH2, CH3, this one, and let's have a look on this one, CH3, CH2, 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 so CH2, CH2, CH3. Now if you see, this compound has more number of carbons than this one, so there will be a difference in melting point. So the melting point for this compound is minus 138 degrees centigrade, that's degree centigrade, and guess what will be the melting point for this compound is minus 95 degrees centigrade. So you can see the clear difference between two molecules. So the concept of this point is, if the number of carbons increases along the chain, the melting point also increases. So the point here is increase. Why this is happening? Because increasing surface area. As the number of carbons increase, the surface area increases. Increasing surface area increases the melting point. Okay, you can apply this concept to any alkanes. I'm just discussing alkanes here. Third point is melting point increases with symmetry. I told you about symmetrical alkanes and unsymmetrical alkanes. Here we can apply that concept, like CH3, CH2, CH, and two CH3s on this CH. So this is then this is C, and it has 4 methyl groups. So you can clearly see which is more symmetrical, this is more symmetrical, CH3, CH3. So there is a plane of symmetry in this molecule which I am drawing, compared to the other molecule which has no plane of symmetry. So this is not symmetrical, this is symmetrical, or you can say this is less symmetrical, this is more symmetrical. Hence the melting point for this compound will be low, that is minus 160 degrees. These videos will help you to predict the melting point of alkanes, like in Untitled, or in general if you are interested in knowing the trends of melting and boiling points. Watch these videos, subscribe these channels, and you will get much more information about organic chemistry or general chemistry in this channel, and we will introduce nanomaterials and nanoscience and other interesting topics in this channel. Keep watching this video and please subscribe. Okay, increasing symmetry increases the melting point. So these were the 3 concepts which I was going to discuss with you, and then last point about the solubility of alkanes. So alkanes are non-polar compounds. As you can see from their structure, they do not have any polar groups, so it's clear that alkanes are soluble in organic solvents which are less polar, like hexane, and alkanes are insoluble in water because water is more polar and alkanes are non-polar. So we're gonna apply the concept like dissolve like in alkanes, like dissolve like. Hexane is non-polar, so alkanes can easily be dissolved in hexane. So just little part of solubility, it's not big, but you need to focus on the melting point and watch my previous video where I have discussed the physical properties of alkanes, particularly the boiling point. Thanks for watching this video. Please press the bell icon and subscribe my channel. Thank you. See you. Bye.